whenever you hit it, you're not allowed to like do crazy stuff, or else they just tee you up. You can't like shoot arrows or anything.
Let's focus on our geometry.
If I ever hit a game, I would go like this. That's all. Subtle. Well, I'll walk.
But people will see it because your hand.
No, he won't. No, he won't. He'll see it, and if he sees it, I'm gonna punch him. Because I got him first.
Let's focus on that.
All right. So last class we talked about in order for two shapes to be congruent, they have to have corresponding pieces congruent. So corresponding sides congruent, corresponding angles congruent. So if I were to have us do a proof right now proving that two triangles are congruent, we would have to first show all three sets of angles are congruent, all three sets of sides congruent, and then we can state that they're congruent. But today we're going to learn 5 shortcuts to prove the triangles are congruent. Instead of having to show all 6 pieces, we only have to show a fraction of those. So for each of these, we have an abbreviation for it, and we can't use the abbreviation in our proofs. We can't use the abbreviation in our proofs. Now, our proofs will use these a lot. Okay, so you'll want to be very familiar with these shortcuts, if you would. So again, what this does is it allows us to, instead of showing all 6 parts, we have to show 3 of the parts or 2 of the parts, and then we can know the triangles are congruent. All right, so our first one we call, our first one we call side, side, side. And so we abbreviate that with SSS. Side, side, side. Now this is technically a postulate. All but 2 of these are postulates. It's technically a postulate. You'll see that in our proofs, though, when we justify or within our proofs. I don't expect you to write postulate there. You can just write SSS, but just know that it's a postulate. So side, side, side simply means if I have all 3 sets of sides corresponding, all 3 sets of corresponding sides congruent, then I can know the triangles are congruent. So take a look at number 1 here. I see I have AC is congruent to DX, CB is congruent to XK, and AB is congruent to DK. So all 3 sets of corresponding sides are congruent. I can say these triangles are congruent by side, side, side. Now again, once you write your congruency statement, you want to make sure you match up the proper pieces. So they went ahead and said ABC, so I'm going to check ABC. That's my 3 mark comes first, so I want DK, X. And just double check, BC should match up with KX. And AC should match up with DX. And we see that is true. Okay. So our first one, side, side, side. Alright, our next one that we have, side, angle, side. Side, angle, side. This is indeed another postulate.
A mnemonic device on SAS.
Yes.
So side, angle, side simply means I need to have 2 sides congruent and the angle in between those 2 sides. Okay, so that's really important. It's 2 sides congruent and the angle in between them. So I take a look at number 2 here. I see I have 2 sides congruent. This is congruent to this guy. This congruent to this guy. And the angle in between them.
Even without the angle, we'd still be able to tell that ST and X3 are congruent.
We wouldn't know. If we only had 2 sides, it wouldn't be sufficient information. Alright, so from here we have, this is proven by side, angle, side postulate. And again, we want to make sure that we have our letters matching up. So I see RST, that's my angle and the 1 mark. So I want my angle and the 1 marks, WZX. And again, just double check, RT should match up with XW. And let's see, we've got ST matches up with XT, so ST, XT. All right, so side, 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 angles. Next up we have angle, angle, side, indeed. Angle, angle, side. And this is actually one of our theorems.
Yes.
So angle, angle, side means I need to have two adjacent angles on the side next to it. So angle, angle, side. They're all next to each other. So it's not that my side is in between, but rather next to it. So let's take a look at, which one do I want? Let's take a look at number 4 here. I can see I have an angle. Come on, smartboard. Set of angles congruent, an angle next to it, and then the side next to that. So I have angle, angle, side, two angles next to each other, and the side next to that.
We have that also.
No, this would be a side in between. Here I want my side next to it, so angle, angle, side. Yeah, so our theorems or postulates tell us not only what pieces we have to have, but also the order in which we have to have it. So here, let's see, we have MZP. So it's going to be my angle without any markings, that would be W over here. And then our right angle, so that was R. And then T, WRT. And again, just double check, MP matches up with WT. All right, so again, these are two angles and the side next to it. All right. You'll wait and see. Let's take a look at number 3. What do you guys think this one's going to be? Okay.
No. Angle in between. Angle in between. Two angles in between sides.
So angle, side, angle. Angle, side, angle is indeed one of our other ones, and this is another postulate, so angle, side, angle. And again, this is going to be two angles and the side in between them. So that's what we have here with number 3. So I have angle matching with angle here, side next to it, and then angle next to that. So this would be our angle, side, angle. And again, make sure you match it up. We have RST, so that's our 1, our no arc, and 2 arc. So I go 1 arc, so J, no arc, K, and 2 arc, L. Okay. Now our last one is quite different than what we've seen so far. So far we've just had a combination of sides and angles. Our last one actually is HL.
Oh, are you sure it's not an angle?
I promise you.
No, I see an example of it.
Alright, HL. HL can only be used for right triangles. Only for right triangles. So technically, even though there are only 2 letters there, there's 3 pieces of information because it can only be used for right triangles. Thoughts as to what the H might stand for?
Half.
Think of right triangles. Hypotenuse. Good. So H stands for hypotenuse.
Half long.
And again, think about triangles. What do you think L might stand for? Leg. Alright, so HL, this is one of our theorems. But again, this can only be used for right triangles. So let's go take a look at what we have so far. Now we see that for number 4, we did have it's a right triangle. And I have my hypotenuse as congruent to my other hypotenuse, but I did not have a set of legs congruent, so I couldn't use HL for that. For number 5, though, we see we do have a right triangle.
Side.
We have a hypotenuse congruent,
2 sides. Yeah.
and we have legs congruent. So this would be HL. And again, so we have VMT.
And
So that was our 2 dash, right angle, no dash. So I want 2 dash, right angle, no dash. Just gave me. And again, you can double check that your information matches up.
Is there such thing as side?
Nope.
Are you sure?
Positive.
I think I have it.
So if we look, we have side, 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 angle, angle, side, angle, and HL. We have nearly every combination of side, angle, side, but much to Henry's dismay.
Angle side side from
This guy is not one of our methods for proving it.
side side. Angle.
First of all, it's backwards, so it doesn't work. But there is an actual reason why. This is not the same as any of these other ones. So here's the issue with it. When we have angle and then two sides following it, we don't have anything to anchor down that other side. Let me see here. So this is something you'll actually encounter in pre-calc. When we have that situation, it makes it's actually two different triangles that could happen. So when we have that situation, let's say that we know this guy. What was it? Angle, angle, side. No, angle, side, side. So we know this angle, and I know this side and this side. Because there is we don't know any information about this angle and this angle here, then that, and we don't know any information about the length of this side could swing out to make that triangle, or I could take that same length and draw it over this way and have a completely different triangle. So there are two different triangles that can be made from it. So we don't have enough information from just those three pieces to know which triangle it is, to know if they're congruent. Now when you get to pre-calc, you're going to use law of sines and law of cosines to solve to find the two different triangles. But that's the reason why it doesn't work, not just because it's a bad word, Henry, but because we also don't know which triangle it's made in. Because I don't know my angle measures here, that means this is free to swing, because this base here we also don't know the length of. So it could either be this longer one, or I can swing it back and have it be a shorter base there. So that's two different triangles. So bad word, not allowed in my classroom, but also not allowed because it's mathematically it's not enough information to know for sure. So these 5 shortcuts, even though we don't have all 6 pieces of information, if we have these 3 pieces of information, that is sufficient information to know the triangles are congruent. If I don't have my triangles meet any of these methods, then we would just say insufficient information. Or just follow whatever the directions say. Triangle's not congruent, not enough info, or insufficient information. Okay. So side, 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 angle, 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 side, angle, side, angle, and HL. I'm going to go right off to the side here so we can refer back to it. So side, 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 angle, side, angle, angle, side, angle, no bad word, and HL. Now, another one that's not up here would be angle, angle, angle. This also does not work.
Why?
Great question, I'm about to ask you that. Why is it that if we have all 3 angles, we don't necessarily know that the triangles are congruent?
Because we don't know that the lines are the same.
Right, so let's think just a very basic example of an equilateral triangle. If I have 2 different equilateral triangles, would you agree that the corresponding angles are congruent? What are the angles in an equilateral triangle? 60, all of them are 60. Now, can't I have a little tiny itty bitty equilateral triangle and then a very large equilateral triangle? Those would not be congruent, those would be similar. Congruent means that it has to have the same size as well. So, although they are the same shape, they're not the same size. One's zoomed in more than the other. Otherwise, I believe we have all our possible combinations. Okay, let's go and just flip it to the next page. So last class, when we were first talking about our congruent figures, we were making our statements based on just observations. Now we actually have markings on our picture. And so we are going to look at these markings and use that information to decide if the triangles are congruent. Now sometimes we can bring in additional information. So let's take a look at this one. Here are some examples of triangles that share a side. So we're trying to decide if we have any congruent triangles here. When they share that side, then that side's going to be the same value in both triangles, right? WM did not change for my left triangle as it is for my right triangle. So WM is congruent to itself. That would be reflexive property. That segment did not change. WM is congruent to itself. So for this first one here, We do have that these are congruent by side, side, side. Because we have these are congruent. These are congruent. And this third side that they share is also congruent to itself. So TMW, what is that going to match up with? X and W, good. All right, let's take a look at our next one. So they've already given us that these sets of angles are congruent and these sets of angles are congruent. By itself, only having the angle is not sufficient information. But let's see if there's anything else we know about our picture. When I take a look here, I see they share this side. Segment AC is the same value no matter whether you're in the bottom triangle or the top triangle.
Is that a line there? It's kind of like...
It almost looks like it was there and whited out. Yeah.
AAS.
So we do have angle side for this guy. And again, that's two angles and a side next to it. So I have angle side, angle side. So triangle ABC, what is that going to match up with?
Easy.
ADC.
It's easy.
Alright, taking a look at our next one here. KN is again going to stay the same for both triangles. So here you might look and be like, uh-oh, that's angle side, that's not allowed. But what type of triangle do we have here?
Right triangle.
Right
So
triangle.
it's HL.
And, well, let's double check that we actually have HL. Just because it's right triangle doesn't automatically mean you have it. Do we have hypotenuse?
Yeah.
Yep. Do we have a leg?
Yeah.
Yes. HL.
Yes. HL means that.
Alright, so we have NQK. What does that match up with? K and M. Do we agree with that?
I don't know.
Yes.
Well, I actually do that. Here's one.
Again, always just do a quick check. NK. Okay, NK, KM, that's the same thing. NQ and KN. Are those the same? Yep. Alright. Now for this one, if two lines are parallel, does that mean that they're congruent? Ooh. I want you to talk with your shoulder partner real quick. If we have two lines parallel, does that mean that they're congruent? Turn to your shoulder partner and say, hey, shoulder partner, what do you think?
Oh, sure.
I don't believe that.
You forgot the important part, Cam.
What's that?
What do you think?
I
Well,
over.
I'm on the fence.
I don't think so personally.
Dude, I'm just trying to have fun today because I'm not really trying to practice with you. That's not going to be great.
You're not trying to go to practice?
No, it's going to be so hard.
It's just doing defense.
Dude, it's good. He's going to be so much.
It's good for
How do you
you.
know that? Why?
Smee's trying to act like he's
All right, bring it back up front. If you think parallel lines are congruent, go ahead and give me thumbs up. If you say no, not necessarily, thumbs down. If we have parallel lines, does that mean that they're congruent? The correct answer is every year I have students that they see this and they're like, oh, they're congruent. We don't know that they are. I can have this
Oh, it's telling
line
you that they're parallel.
and this line. We can have parallel, but those are definitely not congruent, okay? So again, don't trust what the picture looks like, only the information. So it's only telling me that they're parallel, we don't know they're congruent. But what do we know about parallel lines? We've got all kinds of special angles.
They're transversal, you know what I'm saying?
Yeah, we've got this nice transversal happening through here. And a lot of times with these, we end up using our alternate interior angle. So would you agree that this is congruent to this guy?
Yes.
And if I go the other way, looking at these angles, or sorry, these lines, we also have this is congruent to this. What's that? You mean our previous material keeps coming back? All right, so then now we have two sets of angles, but two sets of angles is not enough. Henry, stick with us. So I've got this angle and this angle. Okay, what else do I have in this picture?
The other two lines are parallel.
we have this shared side here. So now we have angle, side, angle, angle, side, angle. Make sure you're careful to get the order right. Notice I'm going one arc, one side, two arc. So then down here, one arc, one side, two arc. So when it says RBF, B has that one arc. But for this triangle, B is actually the two arcs. So again, you've got to be really careful with the order of your letters here. RBF matches up with what? EFB. Good. EFB. So if they share those vertices, that doesn't mean that that letter is going to be in the same spot because it represents different things in the different triangles. Again, just double check. RB should match up with EF. RB, EF. Yeah. Okay. Our one down here, we've got shared side. Can we prove these triangles congruent?
Angle, side, side.
Except that doesn't ever work. Side, angle, side. Good. Side, angle between side. Side, angle between side. And it's at this point I realized we never filled in this up here. What was my method up here?
Alternate.
We did use alternate interior angles, but our method to prove triangles congruent would be angle, side, angle. Good. And again, notice the difference here. These are two angles and the side in between. Two sides and the angle in between. All right. W, Y, Z, what does that match up with?
WXC.
Good. WXC. Okay. Questions with that? All right, they can make the pictures even more complicated. We can have some overlapping triangles. And once again, previous material comes back in. What do we know about this picture up here? What else can I say about it? Yeah, we've got some vertical angles in here. So I can say that these are congruent by vertical angles.
We have vertical lines too, right?
So lines can't be vertical.
Yeah, look.
So over on this page, we had, sometimes again, we have to pull in previous information. We used reflexive property when they shared that side. And we also used alternate interior angles there. Alternate interior angles there. So that's something that those two things we often use. And then we just learned another thing here, vertical angles there. That allows me to get another set of angles congruent. Alright, what method am I using for this guy? I see two sides. Side,
SAS.
angle, side, side, angle, side. Okay. Alright, notice here, they do not already have one of the triangles filled in.
You put it whenever you want.
You get to put it in whatever order you want. I'm going to go C, N, D.
Oh, I forgot one too. No way.
What? So then what is that going to match up with? C, M, D?
A and B.
A, and B. Again, make sure C, N should match up with A, N, and indeed they do. So when you're doing your homework, when you're doing quizzes or tests, you might have instead, maybe you said triangle CDM. That's fine as long as you have then triangle ABM. Okay, so what I'm looking is to see that C and A, then M and N, D and D match.
Let me speak each out.
For this one,
Yeah.
do we have a right triangle?
But like, we have nothing else, so I'm just guessing.
So HL only works for right triangle.
Alright, so no information. Enough information.
Although sometimes that is the answer in special information, we do know more about this picture here. What else do we know about this picture? Vertical angles there and good.
Yeah. So you can't do ASS, the bad word.
All right, now all we have is one set of angles and one set of sides. Right?
Oh,
Parallel
I
doesn't
see.
necessarily
I thought
mean
those-
that the sides are congruent. So that's vertical angles. Let's use our parallel lines. What else do we have? Would you say, Spring? Yeah, we've got a transversal through here, and we also have a transversal through here. So again, if I use alternate interior, here's my set of parallel. If I use this transversal here, alternate interior would be this guy. This guy. Is that enough information right there?
Yes. Yeah.
Yeah, what method would that be?
Angle, side.
Close.
Angle, side, angle.
Angle, side, angle. The side is in between. So angle, side, angle. Henry, are you with us? Smitty, stop distracting me.
Henry's geeking all the time, this morning. He really wishes on the side.
Now, we could also go the other way. We could have used this transversal here. Control.
Yes.
And that would be these angles. And so if you were to have done that instead of the blue, so if I were to use not the blue, what would be my method there?
Same thing.
Careful, my side is not in between them here. So if I'm not using my blue, let me just go and erase the blue so it doesn't throw you guys off. If I would have used my other transversal here, I have two angles in the side. Do you guys agree with that? Okay? These are my two options. Is the side next to the angles or in between them? Is that side in between the green and red?
No.
Okay, I no longer trust Kim because he just throws out stuff.
Oh no, it's not.
Yes.
No, it's not.
No, I use
It would be on the.
Here's
TR.
my side.
It'd be on the line
Yeah.
TR. So
My
it'd be-
side
No, it
would have to
definitely
be
is in
in between.
between.
It's not in between. Here's my red angle,
not
my
on
green angle.
TR.
The side is not in between.
It's not on TR.
Not
Over
on that
here, red and green, the side in between does not have the congruency. It's the side next to it. Angle, angle, side, angle, angle, side. So you could have done by angle, angle, side.
So it couldn't have been.
It could have been.
Oh wait,
both.
how is it ASA then?
When we use
Because
the
when you
other
do
set
an
of
eye,
angles.
oh my god.
So it depends on which set you use.
Get with the
Oh, when you use the other. Okay, I get it.
When I do these alternate interiors, the side is in between, so it's angle, side, angle.
So either of those answers would be right.
So either one would work. And when we have a picture in which there's more than one potential answer for it, I look back to see what markings you have on your picture. Does your markings match up with your statement there? Okay, so just make sure you're double checking. Angle, side, angle, the side is in between. AAS, the side is next to it, not in between. Alright, so be careful with this one. Let's see, we've got, I'm just going to go TUM. TUM, what would that match up with?
IRN.
Joey.
RIRN.
RIM.
So notice how T does not have a marking on it. Which one over here does not have a marking on it? R.
RIN.
U has the 2 arc. Over here, my 2 arc is I. And then M. Again, do a double check. UN and MI should match up. UM and MI.
Where's my guy? Are we ever gonna have an angle J over E?
I feel like we should.
Alright, do we have questions on this?
Angle WASO is congruent to triangle J.
Now our
MOS.
next one here, we have overlapping triangles. Whenever you have overlapping triangles, I highly recommend that you draw them separately and fill in that information. It's hard to keep track of what information goes with which triangle when they're overlapped like that. So I have my triangle over here, QTS. As you can see, it's mimicked over here. And let's see, on there, TS has a 1 dash. And they gave me SR, but not the whole thing, SQ. So I don't have that, but I do have Q has the 1 arc.
Also, angle U.
Yeah, so when I take a look at my other triangle, let's see if it lets me draw here. We can see that one drawn separately. SR has the 1 dash. And then angle U has this angle. So now that we have it separately, we can see a little more easily that we have one set of angles and one set of sides. Is there anything else I can say about it?
No. There's a transversal on that.
It doesn't say any lines are free.
Doesn't say our lines are parallel. I mean, I could do vertical angles down here, but that's not part, that's like within my triangle, so that doesn't help out. Take a look at the top.
Oh, angle bisector.
I love the enthusiasm, but no angle has been bisected.
Angle side. See that little X down there?
Would you guys agree that angle S is in both of it?
Yes.
Isn't S the same angle no matter what?
Yes.
So we have a shared angle S. So this would be another one of those reflexive properties. S is just the same.
So it'd be angle side.
You got it, angle side. Alright, I'm going to go QST.
I corrected Kate who was good.
QST matches up with
USR.
USR.
Yeah. Not gonna lie, young Euclid is the house.
Alright, let's go ahead and bring it back up front. So just a reminder, phone should be away. Earbuds should be out. Attention should be up front. Okay, so again with our last one here, we did have that reflexive property with the shared angle. So just be watching out for that. Damn, so nice to get a join now.
That's what it's like. I was gonna ask you. You always say you have to come go on your own like on the date. You can ask Jack. I was in the bathroom. Wasn't I? Yeah.
Alright, so we have that shared angle, reflexive property, it's in both of them, so just be mindful of that. Alright, so this is another similar one, or another one that's similar to what we've done before. Again, we have the shared side. So we have that's congruent to itself. I have two sets of parallel lines, so I can get quite a bit from there. You're not always going to get two sets, so just make sure you're mindful of which ones are actually parallel. So if I use these vertical parallel ones, I can say that these are congruent by alternate interior. And if I use these set of parallel, I can say these are congruent by alternate interior. So I would indeed have these triangles congruent by which method? What would my method be? Close. Let's flip-flop that. Angle, side, angle. Good. We have two sets of angles, and we have a side in between. So this would be by angle, side, angle. And I'm going to go with HIF. So again, make sure you're careful because these are sharing those vertices. So H doesn't automatically go in the same location. So I have HIF. I can see HI is the parallel side with the one arrow, so I should have G match up with that. I and G we can see are the same. And then again, GH and FI are the two parallel. So HIF, start off with one arc. I should start with one arc here. FGH. HIF.
Yeah.
One arc is where I started. So for my other triangle, I'm going to start at the one arc.
Okay. I'm act like I got it.
Or you can ask questions.
No,
I'm sure
I
you
got
do
it.
get it.
No, I got it.
And again, in the end, just double check. HIFG, those match up. Yes. IF and GH. Yes. And HF and FH. Yes. Okay, do we have any questions with these ones? So let's go and take a look at the back side here. So triangles with insufficient information. So these are just some examples of ones where we don't have enough information. We've already talked about some of these different examples. But our first example here, this is where we only have angles. We have no information about the sides. And so we talked about how these triangles would be similar but not congruent. There's no guarantee that they're the exact same size, because we don't know that their sides are the same. What's what's my issue with these ones over here?
They only have one angle.
Right, so we have an angle, we have a side. What type of triangle is this?
Right.
A right triangle. So I could try for
I
HL,
have a question.
but do I have my hypotenuse?
No.
Yes. Do I have a leg though?
No.
So I
But-
can't use a leg. But what?
You can prove that they're congruent because these two lines are the same, right?
Mm-hmm.
And both the degrees are both 9.
Correct.
So the legs aren't gonna be the same.
Not necessarily. I could have, because we don't know what these angles are, so I could have 30 and 60. Over here I could have 45, 45. I can take this line and I can shift it all that I want because there's no requirement for the lengths here and no requirement for the angles there. So that's why we don't have them.
Yeah, I thought I had a pretty good one, but it's
Alright, so again, this one we would have that they're similar but not congruent. They might be congruent, but we don't know. Similar but not necessarily congruent. Necessarily, is that 1L, 2Ls?
Doesn't matter.
It's 12. Yeah, it doesn't matter. We know what you're trying to say.
There, if it's 1L, then it's just the same thing.
Can we
as
say
1L.
similar?
No. Similar but not necessarily congruent. And then that other one, we didn't have enough information there for that. Our issue here, I already talked about that, where I could take the same length, because we don't know information about this side down here and the angle up there. I could take that same length and just swivel it across over here. And I actually have two different triangles. So we don't know that it's actually the same triangle. Also, bad word.
We can do ASA
Never write that on
So-
any assessment.
or SSA or SSA.
Yeah, that's still an issue. Never write
Will
it.
there ever be anything in math that includes angle side side?
So in pre-cal, in this situation, you will learn how to find the two different
Will it be in
triangles.
that education? I'm so excited.
So now we're not gonna do anything that we're gonna say, you know what, you didn't give me enough information, I'm ahead on.
So this would be insufficient information. Yeah.
Okay.
All right, and then over here, what's my issue here? Because I've got two sets of sides and I have a set of angles.
But
Why
they
can't
don't
I do
give
the-
us the same one. They're both different ones.
Yeah, they're different ones. Here it's
Also says
an
one
angle
line.
in between. Here it's not the angle in between. So if I tried using one of my methods, I don't have the same method for both of them.
Yeah, one of them's SAS and one of them's ASS.
And we also don't have bad words in here. So there you go.
Bad word.
Okay, so these are just some examples of insufficient information.
Bad word for
And
That's a theory.
it's possible that you will have some that don't have enough information. So the biggest mistake students make with this material is assuming information that's not actually there. Saying that parallel lines are congruent when we don't know that they're congruent. Looking at a picture and be like, oh yeah, those angles look congruent. If you don't know it, if you can't justify it with a theorem, postulate, or definition in your head, then don't mark that on your picture. Now, of course, for proofs, you're going to have to write that theorem or postulate. But if you mark that two angles are congruent, you better have a reason to back it up. Otherwise, you probably are making it up. All right, aren't you guys going to try 1 through 8 here? So it just simply says state the method used. We're not writing congruency statements, just which of these 5 methods works. And if there's not enough information, just say insufficient information.
Just put I. Insufficient information.
No, you can write insufficient info or not enough info. But I'm not going to go with I. Right.
Nope.
No, you have to have both the hypotenuse and a leg. right, go and compare your answers with your shoulder partner.
First step in, you have decided let's do another one. But you have all your Alright, let's go ahead and bring it back up front. See how you guys did with this.
He didn't.
Number
Well, I know
one,
he didn't bring me
what
on
did
the
we get?
team to fall in.
What do we get for number one? We got insufficient information or not enough info? Insufficient information. Again, we have that situation where it's not the same information represented. I have two sides and angle, but it's not in the same order. So it's not corresponding pieces. All right, number 4, what do we get?
AAS.
Good, angle side. They share this here, so angle side. Angle side. All right, number 7, what do we get? Side, side, side. They share this guy. How about number 2?
Insufficient.
Insufficient information. They share this, but I don't know if sides are parallel. I don't know if anything else is congruent. So I have insufficient info here. All right, how about number 5?
Just no. No.
Side angle side, good.
Do those look congruent to you?
It doesn't matter.
It's not trust the information.
It doesn't matter.
One side, one arc side, one side, one arc side.
This makes me go crazy. It's like, it doesn't matter.
All right, how about number 8?
Would that be on like a test where it's sine, angle, sine?
No.
Yeah, only look at the markings. Don't trust the figure.
At least make a picture like
Yeah.
relevant.
So you make
Insufficient information.
Sine, angle.
Yeah, but it's not in the it's ASS. Bad words are sad words. You can't use that word again. I'm sorry. I'm sorry.
Okay. Number 3, what do we get?
It could be any of them.
It can be any of them.
There's a possibility.
Sorry, go ahead, Josh.
Wait, what?
Yeah, angle side.
I'm not even catching.
They share this here. Just because it's a right triangle doesn't mean it's HL. We don't have hypotenuse.
See what I said?
All right. Number 6, what do we get at? Is that a 6? Yeah. So we've got our sides here. Now these set of parallel lines allows us to say that we have corresponding angles here. And then these set of parallel lines allow us to say we have corresponding here. So indeed we have, well, we have angle, side angle. So again, 2 angles and a side in between. All right, number 9.
Couldn't you shoot that?
Angle, side angle, angle, side angle.
He would be, Coach would love Gabe. Like, Gabe just got that one right. Coach would love it.
Okay, do we have questions on these?
Gabe, honestly, Chancellor Sports.
I want to draw your attention to a type of problem that you will encounter. I think you might have this type on your homework. So here we have an example of overlapping triangles, but we also have, we basically have 2 sets of triangles where we have to consider. Let me finish putting in some information here. Yeah. Okay, so let's suppose we start off with this picture here. We actually have 2 sets of triangles we have to check. So whenever we're checking to see if triangles are congruent, look for any possible sets of triangles. I, of course, have these overlapping ones here, which I would draw separately so I can more easily compare them. All right, so this would be triangle ABC. And this is triangle BDC. But I also have what I call the bow tie triangles. I also have those 2 compared. So we have 2 sets of triangles we have to check. So let's go ahead and start off with our overlap. I'm going to go and transfer the information that I had from my original picture. So they gave us A and D. And we have these sets. Okay. What else do I know about my overlapping triangles? What else could I say?
Vertical.
Okay, so we can definitely show these vertical angles in here.
And there will be AAS.
Now this, unfortunately, doesn't help us out with our overlapping triangles, but that does help us out with our bow tie triangles. So I could say my bow tie triangles, I could say triangle AEB is congruent to triangle DEC. And that would be by angle, angle, side, angle, angle, side. Awesome. Now let's take a look at our overlapping. Is there anything else I can say from my overlapping?
B and C are equal?
Yeah, we have that they share that bottom there, so I can go and say that. Is that enough information for us to say that they're congruent?
Yes.
No.
Oh yeah, you can't have bad words, I forgot.
No bad words. So just this alone isn't enough information. But we learned something very important last class. CPCTC. Who can explain to me in your own words, what did CPCTC tell us? Thank you to those of you that are looking back at your notes from last class.
Yeah, I know what it means. Cam parts of cam tablet shows.
Corresponding parts of congruent triangles are congruent.
Awesome. So what that means is once I have congruent triangles, then I can say any of their corresponding parts are the same. So the reason why that's helpful for us is because we've just shown my bow tie are congruent. So that means all 6 pieces are congruent. I can go ahead and start filling in the rest of that information. I already have 2 of my angles. I know my 3rd angle is going to be congruent over here. Now that didn't necessarily help us out with our overlapping, but let's see what else we have. I already have these sets of sides are congruent, and for my statement I can see AE and DE are the same. AE and DE. And likewise, I can say that EB and EC are the same.
So because of this, once I know I have congruent triangles, then I can go ahead and say, well, since the triangles are congruent, those corresponding pieces are congruent. Once I fill that information out, then I get a little bit more from my overlapping triangles. Wouldn't AE and EC be the same thing as DE and EB? It's a 2 dash, 3 dash, 2 dash, and 3 dash, right?
Yes.
So that overall side, BD, is going to be the same as this overall side here, AC. And just that piece of information alone would be sufficient information. We could go ahead and say that these are congruent by side, side, side. We could also say side, angle, side.
Whose phone is spazzing?
It's one of those phones over there.
Man, we like go off the wazoo.
Honestly, I'm gonna have to go with this major. I'm feeling games.
So we could have either method here, but that's that's the missing piece that allows us to say triangle ABC. It's congruent to triangle DC. So anytime you have overlapping triangles, check both sets. It's not always going to be the case that you'll have enough information to prove the bow tie, but sometimes proving the bow tie allows you to also get the overlap. Okay, so just heads up for that. Whenever you have overlapping triangles, check all sets of triangles. Questions about that? What is your homework for tonight?
It is 4 o'clock. Sheet 7. Worksheet 3 and 4.
Worksheet 3 and 4.
Yay!
So I want you guys to start working on this. I will say worksheet 3 is probably going to be the faster of the two.
What you think about it with Christian Blues? Yo, hey. Henry, I don't know if I trust you.
Wait a second. Exactly.
No, I'm fine. I trust you.
So worksheet 3,
No, I don't.
listen up.
Yes.
Worksheet 3 is kind of our more basic. There's not a lot of overlapping triangles in there, but we do have some shared sides. We do have some parallel lines. So worksheet 3 will go pretty fast. Worksheet 4, we do have some overlapping triangles. So again, make sure you look to see what other information you can add into the picture. And when we have overlapping, check the bow tie, check the overlapping triangles, see what else can hear. So do make sure you follow the directions. For worksheet 3, you're just simply writing your congruency statement and why. Worksheet 4, you're going to state also, like, if you use alternate triangles, you're going to write that out.